AMD's Ryzen 9000 series processors are finally here, and in today's review I will evaluate one of them and offer you my thoughts. The major features of the Ryzen 9000 processors, according to AMD claims, are new architecture. The AMD Zen 5 architecture boasts substantial improvements to energy efficiency, performance, and AVX 512 VNNI computational capabilities for machine learning and AI workloads. Major IPC gain across a geomean of 13 workloads common to the desktop market. AMD has measured a 16% geomean improvement in IPC. Improved 512-bit AI data path. 4 nanometers process technology. New AMD 800 series chipsets which are not available yet. All X870 series boards have USB 4 on board and concurrently support PCI Express Generation 5 on both the GPU and the SSD, unlike the competition. The only differentiation between the X870 and X870E is among the input-output lanes. New Expo memory speeds. The new AMD 870 series motherboards have been optimized for overclocking and, depending on the overclockability of your specific hardware, can reach DDR5 8000 and beyond. New socket longevity commitment. AMD is committed to supporting this socket through 2027 so that users can buy with confidence in future CPU upgrade support. With these new processors, AMD aims for less power usage, lower thermal loads, and quieter operations, since the cooling systems will be less stressed compared to previous generation CPUs. According to AMD's statements, the thermal resistance improvement reaches 15% and the temperature reduction at the same TDP is 7 degrees Celsius. Overclocking seems to be an important aspect of the new processors, with the new Agisa supporting up to DDR5 8000 speeds. There is a new memory overclocking on-the-fly option and memory optimized performance profiles. Memory overclock is enabled on all AM5 chipsets. The processor also has a new curve shaper overclocking feature. Soon enough, AMD will also release new chipsets for higher performance. However, the new CPUs are also compatible with the existing chipsets, which require a BIOS update to support them. The Ryzen 9000 series currently consists of 4 models ranging from 6 cores and 12 threads to 16 cores and 32 threads. The TDP of the lower 2 models is 65 watt, while the 2 higher models have 120 watt and 170 watt TDP. Against the current high-end Intel processor, the i9-14900K, AMD has the Ryzen 9 9900X, while the Ryzen 9 9950X plays alone at the top of the CPU chain. The Ryzen 9000 series contains a small RDNA 2 based graphics engine in every input-output die, on the same input-output dies used in the Ryzen 7000 series desktop processors. The purpose of this graphics engine is threefold. It significantly extends the applicability of AMD's fastest and most computationally robust processors into the commercial CAD, CAM, and business space. These markets often do not use discrete graphic solutions but tend towards powerful processors. AMD can now extend its performance in these markets beyond APU products. It will aid enthusiast users with troubleshooting should they have issues with a discrete graphics solution. Display outputs from the motherboard will allow users to continue using their PCs even in the event of failing or suspect graphics card. The integrated graphics solution has hardware encode-decode capabilities. These faculties can remain active even in the presence of discrete graphics device. I completely agree with AMD's intent to leverage the smaller 6 nanometers node size to integrate graphics capabilities into each processor. An iGPU can always come in handy. An overview of the Granite Ridge SoC. AMD tried to improve the performance of the Ryzen 9000 series processors without increasing their power consumption, which affects the operating temperatures. According to AMD, the Ryzen 9 9000 series processors will become power limited when appropriate cooling solutions are used. Cooling solutions that are better than those documented by AMD will have ample power headroom for overclocking. This means the better the cooling, the more power the CPUs will be able to get. Hence, the higher their clocks will be. Like the Ryzen 9 models, the lower end ones will benefit from strong cooling solutions. AMD emphasizes that TJ Max is the maximum safe operating temperature, not the absolute maximum temperature. In the Ryzen 9000 series, the processor is designed to run at TJ Max 24/7 without risk of damage or deterioration. At 95 degrees, it still operates within specifications. AMD Eco Mode allows the user to configure their processor to adhere to a lower TDP. For example, a 105 TDP chip moves to 65 TDP, or a 170 Watt TDP chip moves to 105 TDP. AMD Ryzen Master and or the BIOS will make the appropriate socket current and power adjustments to restrict power consumption, as though the chip were natively designed at the new TDP. AMD is transitioning Eco Mode for the 9000 series into the motherboard BIOS CBS option. As this becomes standardized, motherboards might have varied support, which may be found in the overclocking section. AMD expects every compatible motherboard to support Eco Mode. Before the official launch, the new AMD processors were compatible only with some specific mainboards, so I was forced to obtain another Gigabyte X670E Aorus Master to proceed with a review. Without flashing the mainboard to the BIOS that AMD provided, the system didn't boot. To monitor power consumption and every other important aspect of the system, I will use PowerNetics version 2. If you want to see all graphs, read the full review at hwbusters.com. To make this video easier to watch, I will avoid using hundreds of graphs, but I will stick to the most important ones. I use the PowerNetics system to measure power consumption in every significant part of the mainboard with up to 1000 readings per second. The CPU's power consumption at idle is low, at about the same level as the 7600X. During gaming, however, it increases with an average of close to 106 Watt. This is still too low compared to Intel's results, of course, but this CPU is supposed to have a 65 Watt TDP. The CPU starts to show improvements in power consumption and management in heavy multi-thread applications like Cinebench, where its power consumption is notably lower than that of the 7600X. I obtained the peak power consumption readings shown in the graph during the start of the Prime 95 benchmark. As you can see in the corresponding graph, the power spike is high, but after that, the CPU's power consumption drops to around 105 Watt. The energy usage is relatively low in multiple threads, but I would like it to be even lower in single-threaded ones. The maximum operating temperature is set at 95 degrees Celsius, but as you can see in the graph, I was below that with a good air cooler. The improved heat spreader and the lower thermal resistance between it and the CPU's die led to these excellent results. AMD devotes 1.5 pages in its reviewer guide for overclocking, showing that it pays great attention to it. Unfortunately, the PowerNetics software couldn't read any CPU sensor information except code load, so I couldn't extract all the data I wanted. Nevertheless, despite my limited time to deliver this review on time, I only got the CPU 2 days before the NTA's end time, I still decided to try every possible overclocking option. Using the Ryzen Master Curve Optimizer function, I encountered many system freezes and hangs. AMD should look into this. The steps you have to follow to proceed with the CPU's overclock are the following. Enable PBO Advanced and set limits to motherboard. Set PBO scalar to between 7 and 10. Set CPU boost clock override to somewhere between 100 MHz and 200 MHz. I tried 150 MHz. Enabling Ryzen Master Auto Overclock does all of them automatically with a single click, so you can do that without messing with the BIOS settings. Personally, I prefer the BIOS over any application. The next important step is to set the curve optimizer steps. A good start is to perform something like -10 to -15 curve optimizer steps on available CCDs and then look at stability for boot and their workloads of interest. I went with -15 at first, but the results weren't the expected ones, so I also tried -10. A good trick here is to use the Ryzen Master's derive function. This can be done on a per core basis, but will take longer, to automatically derive values and then use those directly or as a baseline and then tweak from there. The new curve shaper allows for fine-grained control of the curve at defined temperature and frequency bands, but because it requires time, which I don't have, I didn't mess with it. You can even set a manual CPU clock, but you also have to set an operating voltage manually. This setting overrides any precision boost overdrive settings. I wouldn't advise messing with this overclocking option unless you know what you are doing, because setting a high vCore value can cause permanent damage to the processor. The last and most important step is to enable the expo profile of your RAM DIMMs, if they have one. This will ensure the best possible RAM performance without any headaches. Whatever I tried, I didn't manage to beat the default plus expo settings combination. As you can see in these screenshots, with the default settings, the maximum CPU frequency might be lower, but it is kept steady, while with the auto overclock function, it drops notably under heavy loads, leading to lower overall performance. I know I use older games, but all I care about is how much the CPU limits the GPU's performance, so it is better to use non-demanding titles, with the only exception, of course, Cyberpunk, which remains a taxing title. The overall performance is high enough, but still the 7800 X3D has a notable lead. I expected higher gaming performance. The difference between the 7800 X3D and this processor is vast, and it costs less than $20 more. The CPU's price is high, not allowing for a high performance per price ratio in either the all CPU test chart or the gaming chart. The Ryzen 7 9700X is expensive at $359. The same goes for the Ryzen 5 9600X, which costs $279. I believe that these increased prices have to do with a lack of competition, so far at least, from Intel, which has serious issues with the 13th and 14th generation CPUs. Although AMD talks about way lower power consumption and only 65 TDP, I didn't see that during my tests. Yes, power consumption has decreased, but not to that degree. What is vastly improved is the operating temperatures because of the updated head spreader and the lower thermal resistance between the die and the IHS. Seeing 62 degrees tops during a Blender benchmark session was a nice surprise. I should note though that in other more taxing benchmarks, for example the 3D Mark CPU profile, I saw up to 75 degrees Celsius temperature, but I use Blender as the standard. The high-performance Noctua NH-D15 G2 cooler with the offset mounting plays a great role in keeping the temperatures low, but the fact is that with any decent cooler you will have this CPU running cool. The major competitor for the 9700X is the 7800 X3D, which costs less than $20 more. It offers slightly increased overall performance in all applications, but has a tremendous lead in gaming, which in my tests reached 30%. AMD created internal competition by setting the new Ryzen 9000 series processor prices so high, and it should drop them to lower levels if it wants the new CPUs to have a successful market career. Moreover, I had trouble overclocking the processor to get better performance, which is the purpose of overclocking. This might be an effect of an immature BIOS. I expect to see the full potential of these processors on the new 800 series chipsets, but until then we are stuck with what we have. Speaking of the new chipsets, it is weird that AMD didn't announce them at the same time as the Ryzen 9000 series. Because I got the CPUs late, just 2-3 days before the NDA's end date, I didn't have the time I wanted to play with them. What I plan on doing next is to fully test the Ryzen 5 9600X and also take a look at AMD's Eco Mode, which promises higher efficiency. Today, everything has to do with efficiency, not only because of the increased electricity prices, but also due to the rapid climate change. So, we have to do whatever is possible to reduce our energy needs and use more efficient devices. That's all, guys. Bye bye.